Welcome to Creative World. In this video, we will solve Chapter 3 exercise problem number 3.6. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Exercise problem number 3.6. Use nodal analysis to find the value of voltage V1 and V0 in given below figure. This is the circuit diagram of given problem. Inside this network, we have to find out the value of voltage V1 and V0 across this 1 kilo ohm resistance. And we have to adopt nodal analysis technique. So without wasting time, let's proceed towards the solution of the network. We know that in order to apply nodal analysis on any network, we have to follow some steps. First step includes finding out the maximum number of node voltage equations that can be retrieved from the network. So using this equation, we can find out this figure. In this equation, n represents the number of nodes that exist in the network. So in this network, there are 4 number of nodes. So maximum 3 node voltage equations we can retrieve from this network. In next step, we have to label all non-reference node voltages. While in this case, this is reference or ground node, all other non-reference node voltages are given. Voltage on this node will be equal to V0 because this voltage is appearing between this non-reference and reference node. So we will update this diagram by indicating voltage on this node as V0. In next step, we have to assume all unknown branch currents along with their directions. Now we will apply Kirchoff's current law on non-reference nodes one by one and will find node voltage equations. We will start from here. On this node, one current is entering while 3 currents are leaving. So KCL equation for this node will be I1 is entering current while I2, I3 and I4 are leaving currents. Leaving currents are taken with negative sign and entering current is taken with positive sign. We have to replace these currents with their respective equations. Current I1 is equal to 12 milliampere. Similarly, current I2 is equal to 2 milliampere, while current I3 will be equal to voltage across this 3 kilo ohm resistance divided by the value of resistance V1 divided by 3 kilo ohm, and I4 will be equal to V1 minus V2 divided by 6 kilo ohm because current I4 is flowing between two non-reference nodes and the direction of current is from V1 to V2, which is indicating that V1 is on higher potential than V2, and current through this resistance will be equal to the potential difference of these two non-reference node voltages divided by the value of resistance. Now in order to omit all denominator values, we will multiply this equation on both sides with 6 kilo ohm. Product of 12 milliampere and 6 kilo ohm will become 72 volt. Product of 6 kilo ohm and 2 milliampere will result 12 volt. Similarly, product of 6 kilo ohm will cancel out with 3 kilo ohm in denominator. Only 2 will left and that 2 will be multiplied with V1. It will become 2V1. Here product of 6 kilo ohm will cancel out with 6 kilo ohm in denominator. Only V1 minus V2 will left. Now subtract 12 volt from 72 volt. It will become 60 volt. And open these brackets, multiply minus 1 with variables inside the brackets, it will become minus V1 plus V2. Now arrange this equation, place this constant value on the other hand side of equal and add values having same variables together. The equation will become minus 3V1 plus V2 equal to minus 60 volt. We cannot further solve this equation, so we will leave it for now and label it as equation A. It is the first node voltage equation of this network. Move towards second node. On this node, 2 currents are entering, I2 and I4, while 2 currents are leaving, I5 and I6. Leaving currents are taken with negative sign while entering currents are taken with positive sign. Now we have to replace these values with their respective equations. I2 is equal to 2 milliampere while I4 is equal to V1 minus V2 divided by 6 kilo ohm, as we have found the value of I4 in previous step. I5 will be equal to V2 divided by 6 kilo ohm, voltage across this 6 kilo ohm resistance divided by the value of resistance, and I6 will be equal to potential difference between these two non-reference voltages divided by the value of resistance. Here again the direction of current is from V2 to V0, so we will consider V2 higher voltage than V0. That's why we have subtracted V0 from V2. In order to omit all denominator values, we will multiply this equation on both sides with 6 kilo ohm. Product of 6 kilo ohm and 2 milliampere will become 12 volt. Here product of 6 kilo ohm will cancel out with 6 kilo ohm in denominator. Only V1 minus V2 will left. Here product of 6 kilo ohm will also cancel with 6 kilo ohm in denominator, only V2 will left. And here product of 6 kilo ohm will cancel out with 2 kilo ohm in denominator, 3 will left, and that 3 will be multiplied with V2 minus V0. Now place this constant value on the other hand side of equal and open these brackets. Multiply minus 3 with values inside the brackets. The equation will become V1 minus V2 minus V2 minus 3V2 plus 3V0 equal to minus 12 volt. Add values having same variables together. The equation will become V1 minus 5V2 plus 3V0 equal to minus 12 volt. We cannot further simplify this equation, so we will leave it for now and label it as equation B. Move towards third node. On this node, one current is entering I6 while other current is leaving I7. So entering current is taken with positive sign and leaving current is taken with negative sign. Now we have to replace these two currents with their respective equations. I6 is equal to V2 minus V0 divided by 2 kilo ohm as we have calculated in previous step, while I7 will be equal to voltage across this 1 kilo ohm resistance, that is V0, divided by the value of resistance 1 kilo ohm. Now in order to omit denominator values, we will multiply this equation on both sides with 2 kilo ohm. Product of 2 kilo ohm will cancel out with 2 kilo ohm in denominator, only V2 minus V0 will left. Here product of 2 kilo ohm will cancel out with 1 kilo ohm, only 2 will left, and that 2 will be multiplied with V0, it will become 2V0. Now add values having same variables together. The equation will become V2 minus 3V0 equal to 0, and it is the third node voltage equation of our network. Up to this point we have retrieved 3 node voltage equations of this network. As we was discussed in earlier stage, we can retrieve maximum 3 node voltage equations from this network. Now we have to solve these equations in order to find voltage V1 and V0. First of all, we will add these two equations together. Equation B and equation C will be added together. This minus 3V0 and plus 3V0 will cancel out with each other. The remaining equation will be V1 minus 4V2 equal to minus 12. We can label this equation as equation D. Now we will multiply this equation A with 4. The equation will become minus 12V1 plus 4V2 equal to minus 240 volt, and we'll add this resulting equation into equation D. This minus 4V2 and plus 4V2 will cancel out with each other. Sum of minus 12V1 and V1 will become minus 11V1. On the other hand side of equal, sum of 240 volt and 12 volt, both are with minus sign, will be equal to minus 252 volt. Now in order to find the value of V1, we will divide on both sides with minus 11. So the value of V1 will become 22.91 volt. We have calculated the value of voltage V1. Now we can place the value of V1 inside this equation A to find out the value of V2. If we succeed to find out the value of V2, we will place that value inside this equation C and will able to find out the value of V0, because it is asked in this scenario we have to find out the value of V1 and V0. In this equation A, V1 is replaced with its value. Now take the product of minus 3 and 22.91. it will become minus 68.73 plus V2 equal to minus 60 volt. Place this minus 68.73 volt on the other hand side of equal. Now subtract 60 volt from 68.73 volt. Value of voltage V2 will become 8.73 volt. After calculating the value of voltage V2, we are able to find out the value of voltage V0 by placing the value of V2 inside this equation C. In this equation C, V2 is replaced with its value 8.73 volt. Now place this 8.73 volt on the other hand side of equal and divide on both sides with minus 3 in order to find out the value of voltage V0, that will become 2.91 volt. So the value of voltage V1 inside this network is 22.91 volt and voltage V0 is equal to 2.91 volt. So this was all about exercise problem number 3.6. Thank you. See you again in next video.